Uh, I'm going to present the chapter 2 for this study. This is basically for the geological aspects of our study. Uh, this was my work for the master's thesis I have done and the research project for the TSUIB and with the collaboration with HBRI. And basically, this was for the geology and the geomorphology and engineering geology and the geotechnical aspects of Dhaka city, where we analyzed and discussed about the different aspects. The major thing was about the amplification and the continuous encroachment of the wetlands and the sensible areas, which are ecologically very important for our city. So we'll go through eventually with this. Masusan, can you hear me clearly?
Yes.
Okay, thank you. So uh, we're living in the city and we're working for the city of Dhaka, where more than 18 million people are living within only 306 square kilometer, which is the which is among the largest 20 megacities of world, and this is the 14th. And as the ERDI parameters, it is within top 20 high earthquake risk cities, and this is very important to identify the earthquake vulnerable areas of Dhaka city, which has been done in several projects but not in detail, where the soil and other factor has been identified. It was segregated work, but this work tried to accumulate all the things in one place, and this is very important to frame the development policy for the future and for formulating the development policies to make this city resilient. Our research question was basically the how vulnerable the Dhaka city is in terms of characteristics of soil. So this question was answered by following two objectives. Number one, the continuous encroachment of water bodies in Dhaka city, and then the probability of amplification in Dhaka city by identifying that. Our expected outcome was the illustration of transformation into built-up areas which ecologically sensitive and which are wetland and depressed areas, and the graphical representation of investigation of the possibility of soil amplification of this city, and identified the areas where soil amplification may occur during any major earthquake probability. And this is the methodology where the study was done, basically collection of the data and analyze those with the deep soil, basically the borehole data, then analyze those things in RGS and representation of map in GIS. So our study area, basically the entire Dhaka city, the greater Dhaka city, and Dhaka city has earned the importance both historically and administratively, what has been explained by Masusan just right now before. And this Dhaka city is surrounding with many seismic vulnerable areas, and this is in the zone 2 of the seismic zone, and the basic seismic coefficient value is Z equal to 0.20, and it is found that floodplain and the depression areas surrounding Dhaka city is peripheral areas where it can be subdivided into lowland the alluvium and highland alluvium, which indicates the probability of soil amplification of those areas. This is the sorry for the hello.
Now it's audible.
Sorry for
it's okay, fine.
Yeah, sorry for the noise. This is the amplification map of the Dhaka city, where we can see the magnitude values of the Dhaka city. And this fault model already discussed by Masud-san. This is the Dauki fault and other faults are overlapping in Dhaka city. And our data collection was basically from the Landsat imagery, which was used to analyze the normalized difference water index, which we call NDVI in terms of GIS, to detect the encroachment of the water bodies from last 30 years. And this study is based on the secondary data sources, especially from the CDMP data and the GSB data, where we took the borehole data. And the GIS shapefile was collected from the Raju, and the satellite imagery was collected by HBRI. And soil amplification factor are calculated from the empirical correlation with the SPT N value and shear wave velocity. And this calculation method was used. Normal NDVI method was from the satellite image X green values, and we took the shear wave velocity formula from Mr. Rahman, and this is calculated by the SPT N values, the borehole data from the borehole data, and this was a non-linear regression of power model. This is as following. We use two types of shear wave velocity for sandy soil and the clay soil. We basically found these two type of data from Dhaka city's SPT borehole data. This is one sample of the SPT borehole data sheet, which we collected from CDMP and the GSB. And this is the surface of the deep soil software, where we inputted those SPT values for the soil location, the layer, and the SPT value, and the class of soil, and other values as well. Then we calculated in deep soil for the shear wave velocity, and we used the Kobe model and also some other model to test the motion and the amplification. Then we imported those data into Excel for our further calculation, for the average velocity calculation, and also for the amplification value. Then we also has got some site classification for the soil, and maximum of those soil from Dhaka city was maximum. Most of them are for subsoil and steep soil profile. And this is the NDVI result for Dhaka city. Here we can see from 1989 to 2019, we have found that the the eastern part and the western part, which was very much wetland and depressed areas, and which were very important ecologically for the environment of Dhaka city, that has been encroached by us or by some development works, and now there is too much low greeneries, where we can see much more greeneries in 1989, but now it's more. Sorry. Sadiasan, can you
Mr.
please?
Jibon, Krishna, Saka, can you mute?
Sir.
Yes, thank you very much for your cooperation.
Thank you, Uber Sensei. So in 2019, we can see the areas, the waterland, the wetlands, and the other water bodies has reduced, and also the greeneries has reduced. Only the built-up areas are showing up in 2019. It has been done eventually. Basically, the massive change was between 1999 to 2009 in this period. And where we inputted those shear wave velocity, we found those values around the city, and we can see the both of the satellite image and also the GIS map, where the shear wave velocity location has been defined and classified. We have categories into 5 categories, and we identified the most vulnerable areas into the bigger dots, and the lower vulnerable areas into the smaller and green dots. Here we can see where the ecological wetlands and depressed areas were maximum. There the development has been done, and this is why it's showing those are more vulnerable. And when we also seeing the illustration of the shear wave velocity and the location map of Dhaka city in terms of amplification, we can see the more vulnerable areas and the less vulnerable areas. And those such results are much important for subsoil investigation in cooperation of the urban planning strategies, because where the next growth centers or the other major development hub would be preferable, these values are important to select the next level development. And based on this subsoil condition, the land use plan should be updated accordingly to the reduce the seismic vulnerability in densely populated areas like Dhaka, and through the integration of such studies will strengthen the risk-sensitive urban planning to build resilient cities. And very few researchers are now working in this field, and further subsoil investigation are required in the peripheral of the Dhaka city, because you can see the borehole location we got very what can I say, very little amount of borehole location. Like, it is important to get the more detailed study and more detailed borehole data to analyze those. It is overall study, and this was a, what can we say, like the starting only. And this government and the policymaker should address the fact and take more initiatives to build a resilient city. So this is from my side, and if you have any question, please ask me. Thank you so much.